Welcome to Monkey Physics IIT JEE NEET Foundations.
Now the next example is, now of course it's somehow the conditions are same in the previous case what we discussed. It starts from rest, moving with a constant acceleration, okay, and they are asking us find ratio of time intervals for successive equal distances of d each. This is the question. Find the ratio of time intervals for successive equal distances of d each. What does it mean? See here is the vehicle, starts from initial velocity 0, starts from rest. Na? So initial velocity 0, it's a keep on moving, acceleration is constant. Now look at here, let me take this is the distance d, and next equal distance d, and next equal distance d, and so on. Now let's take the time taken for this journey is t1, for this journey t2, for this journey t3, and so on. And they are asking the ratio of t1 is to t2 is to 1, t3, so on. Now how can we deal this? Now anyway, what is the formula we can use? Use s is equivalent to ut plus half at square. Now initial velocity is 0, no? Because it starts from rest, isn't it? Now s is equivalent to half at square, and 2s is equivalent to at square, and 2s by a is equivalent to t square. Now here successive equal intervals of distance each d annaru kada, isn't it? Therefore we can write 2d by a under root is equivalent to t. So first we need to understand here t1, if you substitute, then the displacement it covered is d, so it is nothing but root over 2d by a is equivalent to t1. So therefore t1 is equivalent to root over 2d by a. And one more thing, t1 plus t2 we have to write. Why? Because here initial velocity is 0. So initial velocity is 0, only this point the velocity is 0. If you are taking only t2, then you have to write initial velocity at this point, but initial velocity at this point is not equal to 0 because it is moving with constant acceleration. So therefore we should not consider t2 alone. We have to consider t1 plus t2. For this total time, what is that? We represent t1 plus t2. And what is the total displacement it cover? 2d. And what is its initial velocity? 0, and acceleration constant. So that is the reason we are writing t1 plus t2 is nothing but root over 2. In place of displacement, yes, here what should we write? 2d upon a. Therefore t1 plus t2 is equivalent to root over 4d by a. Got it? Now what happened to t2? t2 is nothing but root over 4d by a minus t1. Bring it to the right hand side. So t2 is equivalent to root over 4d by a. What about t1? Root over 2d by a. So then t2 we can write. What should we take common? So I want to take common root over 2d by a, isn't it? Then what happened here? Root 2 minus 1. When you take root 2d by a common, leftover part is root 2 minus 1. Now similarly, t1 plus t2 plus t3 I am writing. So t1 plus t2 plus t3. What is the total distance? 3d, right? So root over 2s by a. So total distance is 3d by a. Hope you are following. So t3 is equivalent to root over 6d by a minus what is t1 plus t2? So t1 plus t2 is nothing but root over 4d by a. Then how do you write t3? t3, what should be taken common? I am going to take common root over 2d by a. Then what is left over? Root 3 minus root 2, and so on. So therefore we can write, so what we can write here, it's t1 is to t2 is to t3 and so on is equivalent to t1 root 2d by a. If you are taking it as 1, this is 1. So the next part is root 2 minus 1 is 2. Next root 3 minus root 2, and then next root 4 minus root 3, and so on. And this is the ratio of the time intervals for successive equal distances of d each when it is valid if initial velocity is equivalent to 0 and the acceleration is equivalent to constant. Okay, yeah.